So in this video, we're going to go over a braking distance example. So you kind of see questions similar to this sometimes. So I'm driving down the street at a constant 30 miles per hour when a kid suddenly runs into the street 50 meters in front of me. That's about half a block or so. It's a half football field. The average reaction time is 1.5 seconds, and the maximum braking acceleration of a normal car like a Nissan Maxima is negative 8.3 meters per second squared. Given this, do I hit the kid or do I have enough time to stop? So when we start to look at this problem, we notice a couple of things. So first off, I'm going a constant 30 miles per hour and he is 50 meters in front of me. So first off, I have miles and I have meters. So I'm going to have to convert something. I also down here have negative 8.3 meters per second squared for my acceleration. So I'm going to want to convert from miles per hour to meters per second. So let's go ahead and do that conversion, and then we'll talk about what we have to do to solve the rest of the problem. So whenever I'm converting, I'm going to start off with what I have, which is 30 miles per hour. So 30 miles for every 1 hour. Now I have miles and I want to turn miles into meters. So miles is on top, so I'm going to put miles on the bottom. And I'm going to convert that to meters. I do know that 1 mile is equal to 1,609 meters. That gets rid of my miles. Now I need to change my hours into seconds. Hours is on the bottom, so for it to cancel out, I got to put it on top. And I want seconds on the bottom. So 1 hour is equal to 3,600 seconds. Hours cancels out. That leaves me with meters per second. That's the unit that I was looking for. So I did this correctly. Now I just need to multiply everything on top and divide by what's on the bottom. When I do that, I get 13.4 meters per second. So now that I've converted and I have everything in the right units, so now I need to actually tackle the problem. There's two things going on here. So I'm driving down the road, the kid jumps in front of me. I don't immediately push my brakes. It takes me a second or 1.5 seconds to see the kid and for that to get processed in my brain, and then for my brain to actually move my foot onto the brake and for me to start braking. During that time period, I'm still moving at 30 miles per hour or 13.4 meters per second. So I have two parts that I have to solve for. First, I have to solve for how far my car moves while I'm reacting to the fact that the kid is in front of me. During that time, I'm going a constant velocity. And then I have the time in which I am screeching to a halt and how much distance that I cover while I'm braking. Those two things get added together, and that's going to give us our total distance that's traveled from when I saw the kid to when I stopped. So let's go ahead and solve first for our reaction time. So kinematic equations, we're looking for distance. So the first go-to is this kinematic equation. Let's see if it works. So I'm looking for distance. I have my initial velocity of 13.4 meters per second. I do have the time because it's 1.5 seconds. That's how long it takes for me to react. Now, what's my acceleration? Well, it's a constant velocity. So my acceleration is 0, which means that this whole side goes away and I'm left with d is equal to VIT, which in other words is distance is equal to speed times time. This is our normal speed equation. So our initial velocity was 13.4 meters per second. The time was 1.5 seconds, which gives us a distance of 20.1 meters. So while my brain is reacting, I'm going to move 20.1 meters. And the kid is 50 meters in front of me. So I haven't hit him yet. So let's see how long it takes for me to stop. Once my brain processes it and I start slamming on the brakes, I can get a maximum negative 8.3 meters per second squared deceleration. So if we go for that same distance equation, then we see that we have our initial velocity because we're going 13.4. We don't know the time. We do know the acceleration, but we can't use this because we don't have time. So we have to use another one. So we do know our initial velocity. We know our acceleration. What's the third piece of information that we know? Well, we're braking we're assuming we're going to come to a stop. And so our final velocity is equal to 0. And that's our third piece of information. So if we have these and we're looking for displacement, then the equation for that is VF squared is equal to VI squared plus 2AD. We need to rearrange this for displacement. So we're going to go ahead and subtract VI squared, and then we can divide both sides by 2A, and that leaves us with our rearranged equation. Now we just need to plug in the numbers. So our final velocity, 0 squared, minus our initial velocity, 13.4 squared, divided by 2 times negative 8.3. Make sure that you do this whole thing before dividing, order of operations. Put that in your calculator and you get 10.8 meters. So we're going to travel farther during our reaction time than we are during our braking time. Now our total displacement is going to be 20.1 plus 10.8, which gives us 30.9 meters. Now, this is not our answer because the question says, do I hit the kid or do I have enough time to stop? And the answer is the kid is safe because he was 50 meters ahead of us and it's only going to take 31 meters to stop. So the kid's okay. So let's add a little twist to this. Let's say I'm looking at my phone. Now, I'm not actually texting, but I did just get a text and I'm going to look down. I'm going to read that text. I just glanced at it for a second. I'm going to take 2 seconds to read that text. Okay. And anybody knows that looking at your phone just by itself and not even really reading it is going to take 2 seconds. So this is a really short glance. So it's going to take me 2 seconds. How is that going to affect what happens here and how long it takes me to brake? Well, during that 2 seconds, I'm still going a constant 30 miles per hour. Once I look up and see the kid, it's still going to take me 1.5 seconds to react to the fact that I saw the kid. So looking at the text is going to add to my reaction time. 2 seconds of text reading means that instead of 1.5 second reaction, I've got a 3.5 second reaction. It's not going to affect how long it takes me to brake, but it is going to affect my reaction time. So right here, I'm going to be traveling a constant velocity of 13.4 meters for 3.5 seconds, which means 46.9 meters. Okay, so I haven't quite hit the kid yet. He's still a few meters in front of me when I see him, but he is real close. Once I hit those brakes, it's still going to take me 10.8 meters to stop. So did I hit the kid? Well, he's 50 meters in front of me and it took me 57.7 meters to stop. So I did hit the kid. And now I'm going to jail. Okay, lecture aside about texting and driving. Hopefully this helped you figure out how to solve this kind of a problem when you have multiple parts to it and you have to think about it like that. Okay, let me know if you have any questions.